Welcome back to our software design and development unit. In this lesson we will look at testing. Our learning intentions for this lesson are as follows. We'll learn how to construct a test plan and what it should contain. We'll learn about comprehensive testing and how it should be conducted. We'll learn about different programming errors in detail. And we'll learn how to use and describe a range of debugging tools. As always, we have some success criteria. For today's lesson, it is as follows. We'll be able to describe the contents of a test plan, be able to describe the components of comprehensive testing and how it should be conducted, be able to identify and describe different programming errors in detail, and we'll be able to identify and describe a range of debugging tools. Let's look at constructing a test plan. Prior to undertaking any software solution, we should produce a test plan. That plan should be systematic in that it will be structured and results documented, and it should be comprehensive in that every single element of the software solution should be tested. When we create a test plan, the requirement specification would be included. We include this to ensure that the software is evaluated and benchmarked against that, and then we know that the client's needs are being met. We would also incorporate a testing schedule. This would allow us to ensure that a set amount of time is set aside for testing and that the entire solution is delivered on time. Within the test plan, we will select the most appropriate tests to ensure that they cover the whole solution, but also ensure that they're practical and we're able to be carried out within the testing schedule. There will be some scenarios that cannot be tested by the development team. These will be covered later in acceptance and beta testing. The appropriate test data must be chosen and should cover normal, extreme and exceptional values for the elements being tested. It should also identify what the expected output and result should be. Normal testing, as we know, are pieces of test data that should be accepted. Extreme are on the boundaries, and exceptional are those pieces of test data we know should not be accepted. All aspects of our testing process should be documented. These can be referred to at a later stage if required. The documentation should include all 5 elements of the test plan, including test tables and visual evidence. All in-house testing conducted by the development team is referred to as alpha testing. During our testing, we will identify some errors. These errors fall into different categories and different types of error. Syntax errors will occur during implementation and can be caused by keyboarding errors. This could be misspelling a variable name or the incorrect use of a programming construct, for example, not closing an if statement. A syntax error will normally be identified by the programming environment. These are generally easy to fix and are highlighted. In this example, we can see that next has been misspelt, causing this syntax error. The second type of error we will look at is a logic error. This type of error will generally be identified during implementation, but normally testing of the software. It will be caused by the incorrect use of numerical values, arithmetic or logic operators. A logic error won't be identified by the programming environment or translator, as there are no errors within the rules or grammar of the code. It will execute and run. However, it will produce an incorrect output. In this example, we can see that the logic error occurs because our comparator operator is the wrong way around. Our third and final error is a runtime or execution error, and these occur and cause the software to crash. It will be identified by the programming environment as they occur when the software is running. Normally, dividing by zero or unexpected user input and accessing out of bounds array indices are common examples. In this example, we would be outside the bounds of the array. This means that we are trying to traverse an array to a point where its index is no longer valid. When identifying errors, there are a number of tools that we would use. These are called debugging tools. The debugging tools that can be used to identify errors are dry runs, trace tables, breakpoints, and watch points. We will look at each of them in turn. The first of the debugging tools we will look at is the dry run. A dry run involves the development team working through the source code manually on paper. They will record the values held about each variable as they go through the code. The development team are essentially taking the role of the computer, ensuring that the code is functioning as expected as they go through it. The second debugging tool we will look at is the use of trace tables. It's similar to the table that would be used in the dry run. However, the computer will be executing the source code as the trace table is being used. The table will be for one specific module or algorithm within the software. We will use this to keep track of the values contained within the variables as the code is being executed. Breakpoints are really useful as a debugging tool. They can be set up to halt the execution of the software at any particular point in the code. When the execution of the code is halted, the values held in the variables can then be inspected by the team. Breakpoints are often used in conjunction with trace tables. When we halt the execution of the code, we are then able to inspect the values contained within those variables and note them down using the trace tables. In this example, we will traverse through an array using a finding max algorithm, and we have inserted 4 breakpoints within our code at lines 23, 24, 25 and 26. We will work our way through the code, and the first line we can see that count is 0 because we are entering the loop for our first iteration. Moving to line 24, where we see number list 0, if that is greater than max, then we would insert that value as max, which is 1 in this case because it's the first value. Again, second iteration of the loop, count is now 1. Max at this point is still 1. The value contained inside this is 3, and therefore we're going to replace that to 3. So we're halting the code at each line and checking the values of count, max and index, and we would repeat that by traversing through the array as we go. Just a special note that breakpoints are also really useful when executing partially completed code, because we can put a breakpoint in and then we will only execute the source code up until that point. Our final debugging tool is a watch point. A watch point is a particular type of breakpoint that will halt the execution of the software. But unlike a breakpoint, it won't stop at a particular line in the source code. It will only stop when the value in a particular variable changes. When setting up a watch point, the value in a variable can be inspected throughout the execution. In this example, we'll look at some code. We've set up a watch point to look at the variable num. We can continue to inspect the value in the variable num as we work through the code. Here we are calling a subroutine called add 5 2 times. We are passing the variable num as a parameter, and in this code we are adding 5 to the value of the variable num. Here we can see the line of code we are executing in yellow. In this case, we're at line 26, where we are at the start of the subroutine add 5 2 times. It is taking in the variable num by reference, and it is going to use that variable within the execution of its code. In this line, we are entering a loop that will iterate twice for count equals 0 to 1. First time round the loop, we are now saying num equals num plus 5, so we are adding 5 to the value already contained within num. We can see the value of the variable num changing to 10. Second time round the loop, we can see the value of num changing to 15. We exit the subroutine, and in line 23 we now print out that number in a list box. Thank you for watching this series of videos, and if you haven't already done so, please subscribe.